Hi scientists, and welcome to Gravity Part 4. I only intended to make a couple of these gravity episodes, but every time I make one, I have more questions at the end of it. So after floating in space, I started to think about some things that I've seen in movies, and I wondered if they made any sense at all. For instance, I've seen movies where people on spaceships are walking around. They're just walking around like they're on Earth. They're being held down to something on the bottom, and they're not floating up. Now, I've seen real pictures of the astronauts in the International Space Station. So what's going on in those movies? Is there some kind of artificial gravity? Is that possible? And then I hear two words that keep coming up all the time: inertia and centrifugal force. And I wonder if those have anything to do with making gravity in space. Finally, the last question is, would it be possible to have a spaceship that had some kind of gravity? So what I'm going to look at today, let's see what happens. Here's a really old episode of Star Trek. There's Captain Kirk, and he's just walking around on his spaceship. You'd think he was on Earth. You'd think they were filming the whole show on Earth. Well, they were filming the show on Earth, and so that's why they have gravity. If you look at this picture of this guy playing his guitar on the space station, you can see his guitar is floating away, and then he's floating away, and there's nothing holding him up. There's no hidden wires that are keeping him. He's actually floating right down there, and he's grabbing his guitar. So looking at these two things, looking at a real video and a fake video, I'm going to say, I think in movies, they should depict the astronauts floating around, but they always say that they have some kind of artificial gravity. So let's see if we can figure out what some artificial gravity is. So let's talk about that word inertia. What does inertia mean? Inertia is the resistance of an object to any change in its motion. That means that, for instance, this baseball right now is perfectly happy. It's just sitting there. It's not going anywhere. But if I transfer a force from my finger to the ball, it's going to make the ball start rolling. Now, once the ball starts rolling, it doesn't really want to stop, right? It would just keep on rolling and rolling and rolling and rolling until something made it stop. If it was nice and flat, just keep on rolling. But then, if I'm going to stop it, what happens? I need to apply a force from the other direction to stop the ball. So let's see. I'm going to start it, and I'm going to stop it. Hi, I'm in my car to talk about inertia. Inertia, remember, is the resistance that any object has to going into motion, whether it's starting motion or stopping motion. And a car, you feel that all the time. If I'm sitting here and the car isn't moving and I'm not moving, I don't have any problem moving around. But in a couple seconds, I'm going to step on the gas accelerator and the car is going to start to move that way. My body isn't accelerating yet, so my body is going to get pushed back against my seat. Once we're cruising and everything is going at the same speed, my body is going at the same speed as the car, then I'll be able to move around more freely. Then I'm going to hit the brakes, and my body will then be going faster than the car because the car is slowing down. So I'm wearing my seatbelt to hold me into place. If I slowed down too quickly and I wasn't wearing a seatbelt, I would fly forward. Let's take a look at what happens. I'm going to accelerate, then we're going to cruise, and then I'm going to brake. We're cruising, and now I'm going to brake. Hi gang. So let's take a look and see what was going on with inertia while I was driving my car. Let's pretend that this box is my car and the golf ball is my head. So when we start out, the box wasn't moving and my head wasn't moving. We were both standing still. But as soon as I accelerated, my head went to the back of the car. Let's see if that happens here. Sure is. It rolled to the back of the car. Once I start going at a constant speed, the ball and the box are moving at the same speed, just like my car and the box were moving at the same speed. But if I should suddenly come to a stop, the ball will roll to the front and then bounce back. So what do you think? Could inertia be some kind of artificial gravity? The answer is inertia could be some kind of initial gravity, but it only works while you're accelerating. So as long as you have your engines on and you're gaining speed, then inertia would hold you down. But as soon as you started to coast, then your body and the spaceship would start to be moving at the same rate, feel like you were floating. As soon as you decided you needed to slow down because you got where you were going and you started to slow down your spaceship, then your body would slam into that. So I'm not sure that inertia makes for a great artificial gravity. But let's look at centrifugal force. Centrifugal force is related to inertia. You can make a body move in a circular motion by forcing it in a direction away from its center. Basically, you have two forces work with each other, one pushing it out and another pushing it to the side. The balance of those two forces creates a circular motion. As soon as one force becomes more powerful than the other, the motion will end. So let's look at this. This is a yo-yo, and the yo-yo has a string. If I hold the yo-yo like this, the string is preventing the yo-yo from falling to the ground. If I turn it like this, what's the string doing? The string isn't really doing anything because if I let go, the yo-yo will fall. If I push the yo-yo in this direction, the string is going to pull it in the other direction down. If the yo-yo wasn't attached to the string and I threw it, it would fly through the air. But what would happen if I threw the yo-yo while it was attached to the string which was attached to my finger? I would throw the yo-yo, and as soon as it would get here and wanted to go that direction, it wouldn't. The string would pull it down. So let's see what happens. Even though the yo-yo is up here, it's not falling down. Because as soon as I stop this and go over there, the yo-yo falls again. How slow can you go before the yo-yo starts to fall? Here's another fun experiment with centrifugal force. Here's a bucket and I filled it up with water. Can you see the water in there? There, believe me now, there's water in there. So, right now, the water is being held by the bucket. The gravity is holding the water in the bucket. But what happens if I turn the bucket upside down? Do you think the water would fall out? Let's find out. Yes, gravity has been proved. I have refilled the bucket with some more water. See, I just want to prove to you that there's actually water in the bucket. Okay, now, what happens if I swing the bucket around? Will the water fall out on my head? Let's find out. Actually, it's kind of a rainy day, so I'm getting wet anyway. So, bucket full of water. I'm going to swing it around. Hey, the water's not falling out. Why isn't the water falling out? Centrifugal force is holding it in the bucket. Well, what happens if I start to slow down? The water starts to slosh and come out. Did I really have water in my bucket? Yes, I did. Did you think I was going to dump it on my head? I know you were hoping for that, but I didn't. And the next question. Could centrifugal force be used to make some kind of artificial gravity? The cool thing about centrifugal force is you don't need gravity to make it work. It works anywhere. All you need to do is have something that's spinning. We live on something that's spinning, and it's going around like this. But we live on the outside of it. We don't live on the inside of it. We live on the Earth and everything on top of it. So why isn't the water flying out into space? You know that answer. It's gravity. The Earth has enough mass to create its own gravity, which holds things to it. So how could we make a spaceship that used centrifugal force for gravity? Imagine we built a giant wheel in space that would be our spaceship. I'm going to use this bicycle wheel to represent the spaceship. It has the same basic elements as the yo-yo. Just like the wheel has spokes, this has a string. When I spin the yo-yo, it goes in a circular motion, just like the wheel does. There's two different forces at work here. There's the force of me pushing it in this direction, and there's the force of the string or the spokes pulling it in this direction. Those two forces work together to make the circular motion. So could you use the circular motion and the centrifugal force to create some kind of artificial gravity? Just like when I swung the bucket around, the water stayed on the inside of the bucket without spilling out. I'm going to use a little Play-Doh here to help me out. I'm going to put a little person right here, and I'm just going to kind of attach him a little bit so he doesn't fall off. Okay? And then I'm going to spin it. Let's see what happens to our astronaut inside. Can you guys see that the little spaceman is not falling off? He's being pushed to the inside edge and he's not falling off. Look, even when he's upside down, he's not falling off. I have a question though. What would happen if I put him on the outside? Like if this was the Earth and we're on the outside and I put him up here, what would happen to him? Do you think he's going to fly off into space, or is he going to be able to go around? No, he fell right off, and he fell off, and you know the reason why, because the wheel does not have enough mass to make its own gravity. So I'm going to try one more time just to see what happens. I'm going to put our space people inside of our rotating spaceship, and I'm going to spin them around. This kind of spaceship has been theorized about. It would have to be huge for this to work. But it is possible. Check out this video. What you're seeing here is a design for a gigantic spaceship. It's not really a spaceship so much as it's a colony, a place where generations of families would live as you travel across space. It was originally dreamed up by an American physicist and science fiction author named Gerald O'Neill, and so this is called an O'Neill cylinder. But it's not really a cylinder because the cylinder is curved. It's more of a donut shape. And it rotates around a central hub, and while it's rotating, it's creating centrifugal force, which is making an artificial gravity. Inside of the cylinder, or the donut, you can see there are farms and cities and places for people to live. This is so big, you might never know that you were on a spaceship. You would just be hanging out and living a life. All right, scientists, I hope you learned a little bit more about gravity today, about inertia and about centrifugal force, and about the possibilities for creating some kind of artificial gravity in space. If you have any questions about gravity, please ask. Let's figure it out. Okay? Have fun.